Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. Today, we are going to discuss about water and its treatment, which is first chapter of engineering chemistry. Coming to overview presentation, first one is introduction to hardness of water, hard water and soft water, types of hardnesses. So let us start with introduction to water sample. As we know very well that water is nature's most wonderful and abundant compound. That means water in a chemical sense today in our class we are going to discuss about. So before going to that one, actual where it comes from, that means sources of natural water, what kind of impurities may it have, and what are the major applications of water as a natural resource. So all those things we are going to discuss now. Then we will go for actual topic, that is water in a chemical sense. So water is nature's most wonderful and abundant compound. It is not only essential for all our lives, that is human beings, plants, animals, but also it occupies a unique position in the industrial side also. It is used as a source in the generation of steam, and it can be used as a coolant in power plants and also in chemical plants. For maintaining uniform temperature, for reducing temperature in power plants and in chemical plants, water is acting like a coolant. Very good example for coolant. And most important application in industrial side, it is water is used as a source for steam generation. And also in other fields like production of steel, rayon, paper industry, atomic energy, textile industries, chemical industries, ice factories, and in air conditioning equipment, irrigation, etc. So for drinking water purpose and for irrigating fields, generally we depend upon water. So as we know very well that the major source of water comes from rainwater. Whenever heavy rainfall occurs, that resultant runoff water, sometimes it is absorbed by roots of the plants, and the resultant runoff water will mix up with surface water. This rainwater, it is probably the purest form, as we know very well, of natural water. Other sources will include river systems, lakes, streams, ponds, and then groundwater resources. As we know very well that water comprises of H2O molecules. Water in a chemical sense, if you notice, it will contain water molecules, H2O molecules. That means it is a combination of hydrogen and oxygen, right? Sometimes this natural water, as we are talking about this rainwater, which is in the form of river systems, lakes, streams, and underground water resources, generally it is getting contaminated nowadays by different types of impurities. So different categories are there for various impurities present in the natural water. First one, it is physical impurities. These physical impurities will include turbidity. This is purely due to the presence of suspended solid particles or mud particles that were present in the water. That means I'll give you a clear example. Especially in rainy season, if we fill that river water, especially in rainy season, into a transparent water bottle, generally we can notice some kind of brown color in that water bottle. Brown color is purely due to presence of suspended mud particles or solid particles. And if that water that you have collected in that glass bottle, if you keep it aside without any kind of disturbance for several hours, then what it will convert to is, it will get separated to two different layers. All the suspended solids of clay, they'll settle at the bottom of that water bottle, and in the two layers, mud particles will settle at the bottom because of density variation, and the water which is present in the upper layer, it is very clear in nature. So if you shake that water bottle again we can notice a change in its color, that is brown color it will convert to. So this is purely due to presence of suspended solid particles. So that kind of property is what we call it as turbidity. So especially for natural water, that is like river systems, lakes and ponds, especially in rainy season, we can notice this kind of property. Odor is nothing but smell. So this also comes under physical impurities. And then color. Just now we discussed about turbidity. It is able to impart color also. And then second category of impurities include chemical impurities. If some kind of chemicals they were present in dissolved state in the water, then they are able to impart some kind of properties, right? So and then mineral impurities. Say for example, some kind of salts of calcium and magnesium, if they were present in dissolved state in water, then it is able to impart some kind of properties like hardness, alkalinity to the water sample. So these things will come under mineral impurities. And coming to the chemical impurities, if chemicals were present in the water sample, then they are able to affect its pH of the water. And finally, the last category it is of biological impurities. As we are aware of this biological impurities, that means presence of microorganisms, algae, fungal bodies in the water, they are able to cause waterborne diseases like typhoid, cholera and all. So because of these kind of impurities, the quality of the water gets changed. So sometimes if these kind of impurities are crossing their permissible limit, then they need removal. So in this chapter, we are going to discuss about a property called hardness that is produced due to presence of minerals in the water sample. So and as we know, water in a chemical sense, that is it comprises of H2O molecules and it is made up of hydrogen and oxygen. And one more important property that is in a chemical sense related to water, it possesses polar nature. It possesses polar nature. So water generally, in general, it is having a pH that is equal to 7, which is neutral in behavior. Because of presence of some kind of chemicals in the water in dissolved state, there may be a chance for getting a change in its pH value. So basing on that one, sometimes its nature will change. And moreover, this water molecules, that means water it is having a polar nature. That's mean it is an example for polar compound. So because of its polar nature and ionization capacity, water it is having a very high dielectric constant, as well as it possesses very good thermal insulation properties. So let us go with actual topic for today's class, that is hardness of water. So actually this hardness that is present in the water is considered as a characteristic property which prevents a lathering of soap. That means formation of foam. Whenever that soap, by consuming a little amount of water, it is able to produce lather, or we will call it as foam. So if hardness it is present in the water sample, then it is able to prevent or avoid that lathering of soap. So why it is going to avoid, or why it is going to prevent that lathering of soap? This is purely due to the presence of salts of calcium and magnesium, and sometimes heavy metals like iron, aluminium. If they were present in dissolved state in water, then they are able to impart a property called hardness to the water sample. So what do you mean by hardness? Means it is a characteristic property that exists for a water or a water sample, by virtue of which it is able to avoid or prevent lathering of soap. When a sample of hard water, if it is mixed with soap, generally, can you define soap? Means soap is defined as sodium or potassium salt of long chain fatty acids. Generally, fatty acids examples will be like oleic acid, palmitic acid, stearic acid. Stearic acid means its molecular formula it is C17H35COOH. C17H35COOH. That is the molecular formula for stearic acid. Similarly, palmitic acid means C15H31COOH. Oleic acid means C17H33COOH. So these are nothing but long chain fatty acids. When they were treated with strong base like NaOH, that is sodium hydroxide, or potassium hydroxide KOH, then they are able to produce their corresponding salt. So that is what we call it as soap. Soap means sodium or potassium salt of long chain fatty acids like oleic acid, palmitic acid or stearic acid. So now when a sample of hard water, when it is treated with soap, soap means sodium or potassium salt of long chain fatty acid. So what it will do? after consuming more amount of soap also, it is unable to produce lather. So it is unable to produce lather. That means lather it is not produced. So such kind of water we will call it as hard water. What actually happens when we treat this hard water sample with soap? So let us go with its mechanism part. As I told you, soap is nothing but sodium or potassium salt of long chain fatty acids like oleic, palmitic or stearic acid. So in this case, I am going to consider soap that is produced from stearic acid. That means its molecular formula is C17H35 COOH. So this is molecular formula for stearic acid. So it's a sodium salt I am going to consider for the mechanism part. So if this soap it is treated with water which is having hardness. Say for example, calcium chloride if it is present. As I told you, salts of calcium and magnesium in dissolved state in water are able to impart hardness to the water sample. So I have considered the example of calcium chloride. So if water it is having hardness, that is due to the presence of dissolved salts of calcium and magnesium. Say for example, calcium chloride I considered, and this one if it is treated with soap, soap is nothing but sodium stearate C17H35 COONA. So then what it will convert to? It will convert to calcium stearate, which is an insoluble scum. Instead of producing lather, if water is having hardness, then it is able to produce an insoluble precipitate which is having white coloration. So that is what we call it as scum. So that is its molecular formula C17H35 COO taken twice calcium. So it is an insoluble precipitate. So along with that NaCl will be produced. So if I consider the water which is having, as I told you, hardness is purely due to calcium and magnesium salts in dissolved state. In the second reaction, I consider the example of salts of magnesium. In that I considered magnesium sulfate. So this is, if this is present in the hard water sample, then after treating with soap, here what I have considered, soap is nothing but sodium or potassium salt of long chain fatty acid of stearic acid. So in this case, I considered sodium stearate. So sodium stearate, when treated with hard water sample which is having magnesium sulfate in that one, it is able to convert into its corresponding salt, that is magnesium stearate. So this is also nothing but insoluble scum. Instead of producing lather, we can notice the formation of a white color precipitation that is called scum. So along with that sodium sulfate will be produced. So basing on this soap consuming capacity, just now so far what we have discussed, that is basing on reactions 1 and 2. Basing on soap consuming capacity, we can define hard water and soft water. So what is soft water? Water which produces lather easily on consuming little amount of soap, that is called soft water. By consuming little amount of soap as well as small amount of water sample, it is immediately able to produce lather. So such kind of sample is what we call as soft water. On the other hand, the water which does not produce lather easily even after consuming a lot of soap. So you have to underline this line. Even after consuming a lot of soap, water which is not able to produce lather, instead of lather it is able to produce a white color precipitation that is called scum. It is called hard water. So far what we have discussed, introduction to water sample, and then hardness is a kind of property which is purely due to dissolution of some kind of salts in the water sample. Those are salts of calcium and magnesium. So and then what is the mechanism that is happening in water sample when it is treated with soap. Okay, if you notice these two pictures, so in this is the picture that is revealing the nature of the water as soft water. That means this entire part it is of foam, and this is the clear part, it is of clear water. So if it is for the case of hard water, if you test its soap consuming capacity, so instead of forming this kind of foam, it is producing a white color precipitation, so which is visible here in the conical flask, that is nothing but example for hot water sample. So, and one more thing, as I told you, some salts of calcium and magnesium are responsible for imparting hardness just as a property to the water sample. What kind of salts are responsible? First one is calcium bicarbonate, Ca HCO3 taken twice. Second one is magnesium bicarbonate. Okay. Third one is calcium chloride. Fourth one is magnesium chloride. Fifth one is calcium sulfate. Next one is magnesium sulfate. So these salts are responsible for imparting a property called hardness to the water sample, right? So first two are bicarbonates of calcium and magnesium, and next one are chlorides of magnesium and calcium, and the third one it is sulfates of calcium and magnesium. If you notice, in all these six salts, calcium and magnesium are common cations. So cations that were present in all these six salts are calcium and magnesium. If it is for the case of anions, anions are bicarbonates, HCO3 minus, chloride ion, Cl minus, and then sulfate ion, SO3 minus 2. So either in its ionic form or salt form, we can express hardness of water. So because of dissolution of all these six different salts in water sample, water is able to get hardness as a property. So let us go with different types of hardness of water sample. So for you have discussed what kind of salts are responsible for hardness. So now let us go for its two different types. There are two different types of hardnesses. One is temporary hardness, or we will call it as carbonate hardness. Why it is named as temporary hardness means this can be easily removed from water by boiling the water sample. This is named as temporary hardness, and it can be easily removed by boiling the water sample. And this kind of hardness it is produced purely due to presence of dissolved bicarbonates of calcium and magnesium. That means calcium bicarbonate and magnesium bicarbonate, if they were present in dissolved state, or any one of these two, at least one, calcium bicarbonate or magnesium bicarbonate, or sometimes both together they were present. So if their presence it is there in the water sample in dissolved state, then that water will acquire a hardness that is called temporary hardness. As it is produced due to bicarbonates of calcium and magnesium, it is named as carbonate hardness also. And it is very simple to remove. It can be easily removed. How? Simply by boiling the water sample. What happens when water sample which is having temporary hardness if it is boiled? So let us go with that reaction part. So as I told you, calcium bicarbonate and magnesium bicarbonate are responsible for imparting hardness to the water sample. So what happens if that water sample, if it is heated or boiled? So if it is boiled, then these dissolved bicarbonates of calcium and magnesium will convert into insoluble calcium carbonate and magnesium hydroxide. Magnesium hydroxide, which are purely insoluble in nature. So these will convert into calcium carbonate and magnesium hydroxide in nature, that is they are insoluble in nature. So along with that, water and CO2 will be produced. So these are converting into insoluble precipitates which can be easily removed by filtration. These can be easily removed by adopting filtration technique. That's why it is named as temporary hardness. Temporary hardness, it is produced due to presence of dissolved bicarbonates of calcium and magnesium that were present in the water sample. So this can be easily removed by boiling the water sample. What happens if this water sample, if it is boiled, initially which were present in dissolved state or soluble state in the water, that is calcium bicarbonates and magnesium bicarbonates, after boiling they will convert into insoluble calcium carbonate, that is CaCO3, we convert into precipitate form, and magnesium hydroxide, which is also an insoluble precipitate, which is produced. So as these two are insoluble in nature, simply by adopting the filtration technique, we can remove these two impurities from the water sample. So water becomes free from the temporary hardness. Right. Let us go with the second type. What is the second type of hardness? Permanent hardness, or we will call it as non-carbonate hardness. So what do you mean by permanent or non-carbonate hardness? So this type of hardness is imparted to the water sample if the water is having dissolved salts of calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, like alum, or we can call it as aluminum sulfate. So calcium chloride, magnesium sulfate, and magnesium sulfate. So if these were present in dissolved state in the water, then that water will have a type of hardness that is called permanent hardness. So why it is named as permanent hardness means, just like in the previous case, if you boil this water sample, so it will not be converted into any insoluble form. So these need a special techniques for their removal, or we can call them as purification. That's why it is named as permanent hardness. That means it cannot be removed simply by boiling the water. They need special techniques for their removal. So that's why we will call it as permanent hardness. So as anion, coming to the anion part, it is not having any carbonates. That's why it is named as non-carbonate hardness. It is also known as non-carbonate hardness, or also we can call it as non-alkaline hardness. Okay. How many types of hardnesses so far we discussed? There are two different types of hardnesses: temporary hardness and permanent hardness. See, this figure, it is revealing some kind of ions, that means the cations like calcium, Ca plus and magnesium. If these were present in water in dissolved state, so many ions will be present. But the ions that are responsible to exhibit this soap consuming capacity, basing on that one, we will define hardness of water sample. That calcium ions and magnesium ions are able to consume that soap, thereby converting into corresponding stearates, or we can call them as salts. So as a result, hardness will be imparted to the water sample. It is expressed in terms of ppm, that is parts per million. So basing on that presence of ions, it is getting increased. So this is the formula for finding out total hardness of water. Total hardness of water sample, it is calculated or determined by adding, that is sum of temporary and permanent hardness. So by adding temporary, first we have to calculate temporary hardness, and then we have to calculate permanent hardness. After adding these two, it will give the total hardness of the water sample. So how to calculate temporary hardness means simply that some amount of water sample we have to take. And then if it is boiled, and then we are able to notice some precipitate formation, we have to filter that one, and then water becomes free from temporary hardness then. So then we have to calculate for permanent hardness. So in this class, we discussed about introduction to water sample, or introduction to water. Okay. Introduction to water as a natural resource. And then introduction to hardness. What do you mean by hardness? How it is produced to the water sample. What salts are responsible for causing hardness? And then types of hardnesses. How many are there? Two different types are there. First one is temporary hardness. Second one is permanent hardness. In the next class, we discuss about expression of hardness, units of hardness, in how many ways we can express hardness that is present in the water sample, and some numerical problems based on that units, and then relationship, or we can say interlink between different types of units of hardnesses. Thank you very much. That's all for today's class.